Hi guys, this is Felchner. Today we're going over direct variation. The objectives here to determine whether a data set shows direct variation, to determine equations for direct variations, and then to solve problems involving direct variation by using proportions. Okay? Alrighty. So, direct variation is when each ordered pair, x and y, and a direct variation function, y equals k times x, k has to be a non-zero fixed number, and k is called the constant of variation. So right now we've been talking about slope, right? So the constant of variation, I want you to think about that, okay? For each point, in order for slope to be a straight line, okay, it has to go up by a certain constant amount each time, right? Going up 3 and over 1 between each point, okay? All right, so I want you to have your purple book open on page 172, and I want you at the top, you'd see that table with the green heading at the top, talking about ticket sales and revenue, okay? Alrighty, so when you're given a data table like this, your first thing is you want to write an ordered pair for each x and y value. So in that first box, on Friday, it says 205 in ticket sales and then $615. So that's your first point right here. Let me see this. That's your first point right there, right? The second one says 310 for $930. And your last one is 170 tickets sold for $570, okay? So you want to graph each point, okay? So, and you won't have to do this on your homework. We're going to do this part together since the graphs are going to look pretty big. And we'll go over how to set that up. So then you would graph each pair on the coordinate plane. After you've plotted those points, you'd want to take a straight edge and draw a line through each point, making sure that they all connect, okay? And that is shown there on that graph on page 172 for you, okay? This particular graph in your book of this data set is linear. It is a continuous line that goes to the point of origin at 0, 0. That's where it starts, and it goes straight up through there, okay? All right, I want you to think about what K represents, okay? K represents your slope, okay? Because slope is not only rise over run, but it represents unit rate and direct variation in everyday life math. So when we're talking about how much money that we're making off ticket sales, okay, this is what people do at One Direction concerts, at Taylor Swift concerts. How much money are we making? Is it constant? Does it go higher in some cities and lower in other cities? Okay, people use this in everyday life, all right? Alrighty, so the next step that we're going to go to is to show direct variation. You can also compare ratios by finding the value of K. So we're going to take the same information that we just worked on in that data set up there from the table. So we're going to do x equals 205, that was our first coordinate, and y equals, where's that, 615. So that's from our first setup there, up top. Okay, so we're going to do y equals, I can get it going here, k times x or the equivalent, which is y, which is k, and then y over x, because we divided by x on both sides. Okay, so all you're going to do is set it up just like that. So we're trying to find out what our k is going to be equal to, so we're just going to plug in our values. So this is going to be k equals 615 over 205. Right? Yeah. You can simply type that in your calculator if you don't want to do it by hand. And that is going to be equal to 3. So k in our first coordinate pair is going to be equal to 3. Okay? So take a moment, copy that down. I'm going to pop over to our next value here. So we have x equals 310, and y is told to be 930. So the same thing, right? Y equals k times x. I divide by x on both sides to see, because we're trying to find the value of k. So we know it's going to be equal to k. Our y is 930. Our x is 310. Okay? When you do that division, you're going to see that k equals 3 again. Okay? I'm not going to show you the last one when x equals 170 and y equals 510. I want you to copy that down in your notebook. So it's right by the other examples that we just did in the problem. So when everything equals the same number, okay, so when the ratio of variation is constant, like it is there, goes up by 3 by each coordinate set, okay, the revenue Y varies directly as the ticket sales of X. So when Y varies directly with X, that's our direct variation, okay? So again, that's just the second way to see besides plotting the points on a graph. If you don't want to plot the points on a graph, you don't have to. Do it this way right here. If I can show you right here. Okay? When I switch it up, so K equals Y over X. Okay, same thing here, okay? Alrighty, the next way is you can find the equation of direct variation by finding the value of the constant of variation, which is K, and then substituting this value into the equation Y equals K times X. So right here, this is going to tell you that Y varies directly with X, or as X. Okay, so we're going to set it up as Y equals K times X. Let's do purple. Okay, we're going to switch this up by dividing this by X on both sides. So we're going to get K equals 35.1 over 13.5. Okay, again, I don't expect you to do this by hand right now. Have a calculator or your smartphone out so you can type that in. You see that K equals 26.1. I'm sorry, that's not right. I didn't do my math correct either. Equals 2.6. Okay, so you're going to write it as Y equals, you're going to go back to your original equation. Okay, this told you right here that K equals 2.6, so you're just going to plug that in for K. So Y equals 2.6x. Okay, that is your equation of direct variation. Okay, so it's going to go up by about 2.6 each time between each coordinate. Okay, so now you can also solve problems that involve direct variation by using equivalent ratios or proportions. So this is talking about like word problems like pay per hour or speed per hour or anything like that. So if x1, I'm going to fill this in, if x1 and y1 and x2 and y2 satisfy the direct variation relationship y equals k of x, then it's going to look like this. You're going to have y1, I'm sorry, my pen's not working, y1 over x1 equals y2 over x2. Okay? So if we look at that first example, it's talking about pay per hour. So I want you to take a moment, read it, then try to set up, and then it's actually already set up for you. So just copy the way that they set it up in the textbook, and then we'll go over it in just a minute. Okay, so hopefully you finished copying that problem. So you set up just like you would any other proportion that we've done in the past. So since Brian works per hour for every 12 hours, he makes $102. So now he wants to find out, well, if I work 37 hours, how much am I going to make? So you're going to set it up just like that. I would divide 102 by 12, and then multiply each side by 37, and that's how you get $314.50. Okay? The last example we're going to do is that second example below where it says consider a case in which y varies directly with x. Okay? So it gives you that y equals 109 and 56, and x equals 8.3. Okay? Wants you to use a proportion to find the value of y when x is 2.2. Okay? So the same thing, y1 over x1 equals x2 over x1. So it gives you the first one of 109.56. That's our x1 value. Our y1 value. Our x1 value is 8.3. And it says right there it's going to equal, I believe it gives you the x value, which is 2.2. Okay? So let's do y2 over 2.2. Oops. Okay? My advice is to divide 109.56 by 8.3. Again, more than welcome to do this in your calculator. No problemo. Okay? So that would be 13.2. equals y2 over 2.2. So we're going to multiply by 2.2 on both sides. Okay, and that should give you 29.04. It's going to be your, 29.04 equals your y2 value. Okay, so when y equals 29.04, x is going to equal 2.2. Okay. I know this is a lot of information, but just take these notes down and we'll work on this a ton in class tomorrow. Okay. All right, guys. Good luck. Bye.